Okay, our next speaker is Dr. Siti Naquiah Pauzi and Amiera Syazlin Azhar. I think that co-investigators and are currently studying in the Masters of Science Technology Management and the Master of Science Intelligence System, respectively, at University Utara, Malaysia. Both authors are supervised by Mohamad, Ghozali Hassan, Binti Harun, Noraini Yusoff, and Koben Chu, senior lecturers and researchers from University Utara, Malaysia, University Malaysia Kelantan, and the National Fish Health Research Center, respectively. The authors have a growing interest in the fields related to image processing and artificial intelligence. There you go. Their talk today is about an intelligent protozoan white spot fish disease detection. Thank you, and please take the floor.
Protozoan white spot disease is one of the leading causes of fish disease outbreaks, which could impair the production and cultivation of diverse species among mariculture fish populations in Malaysia. Good day, my name is Amiera Syazlin Binti Azhar. I represent my team and will present an incentive could be offered, namely an intelligent protozoan white spot fish disease detection. The aquaculture industry in Malaysia has been an important contributor to the nation's economy by providing source of both food and income to the nations. The technological revolution has turned this business into one of the fastest growing food industries in Malaysia, according to the National Transformation 2050 goal for the country's smart communities in 2050. Malaysia also became one of the world's top 15 aquaculture producers, with an estimated total output of 521,000 tons. Hence, considerable effort should be expended on aquaculture fish management and production to ensure the sustainability of fish production to meet the country's 30.75 million population demand. Fish disease outbreaks are one of the obstacles to the production and cultivation of species, which might limit the sector's development and expansion. In Malaysia, a parasitic disease known as protozoan white spot disease or cryptocaryoneasis caused by active cryptocaryon irritants in saltwater has been a major source of disease outbreaks since mariculture was introduced. The parasites infect fish by attaching itself to the fish body and move beneath the skin to feed on skin, gills and eyes, which then weakening those organs' ability to function. Infected fish would suffer small white patches, skin discoloration, mucus hypoproduction, and appear thin. With the fourth industrial revolution's emerging technology, intelligent detection of white spot disease in the early stage is critical for preventing outbreaks from worsening. The strategies of using image processing on underwater images would effectively ease the classification process to detect white spot fish disease in early stage. Hence, this study demonstrates a new procedure for white spot disease detection using underwater image, concerning on the development of integration between contrast-limited adaptive histogram equalization, or we call it as CLAHI, and convolutional neural network, CNN. Underwater fish image datasets were prepared from the 4K footage shot taken using GoPro camera at National Fish Health Research Institute NAFISH, Batu Maung, Penang, without any artificial light or filters. The datasets contain images of normal and protozoan white spot infected fish. The detection procedure begins with image processing to enhance the image degradations as an input for the next classification process. As we said before, this study used an image enhancement technique, namely contrast-limited adaptive histogram equalization, or we call it as CLAHI, to improve contrast and highlight the image's important features. Enhanced images would be processed using CNN to detect the presence of white spot disease. There are two sets of classes to be classified, namely normal and infected. The datasets consist of 60% infected fish images and 40% normal fish images. In this study, CNN algorithm was chosen as classification method to classify white spot disease. A total of 30 normal fish images and 30 protozoan white spot infected fish images were tested. Tables shown demonstrate the accuracy of all the tested images. These accuracies determine the percentage of the prediction model to classify each tested image. Values shown in the diagonal pattern accurately detected normal and infected fish images. 29 infected fish images were correctly detected, while a single image was wrongly detected as normal. Meanwhile, a single normal fish was incorrectly detected as infected, and the rest 29 were correctly detected as normal. 96.67% of accuracy has been achieved for protozoan white spot fish disease detection. The results demonstrated the potential of the proposed approach to detect protozoan white spot disease based on underwater images. The ocean covers 71% of the Earth's surface, making it a complex task for diagnosing fish disease due to the challenges of underwater environment, and it demands high level of expertise. As an alternative to the traditional method, the demand of fish disease detection study using new approach should be fulfilled to continuously sustain the productivity of aquaculture sector. One of the efforts, the study strategy of using image enhancement technique on the degraded underwater images, successfully making the classification process more accurate in detecting the contagious protozoan white spot disease. Combination of CLAHI and advanced technology of CNN has showed the potential to detect the disease based on underwater images. 96.67% accuracy achieved demonstrates that this method could be crucial to early outbreak prevention at the same time as the participation of fish experts. This research tries to improve underwater image detecting algorithms. Even though most earlier research is not limited to fish disease detection, this work shows how the integration model could be used to detect the outbreaks at an early stage. These results could serve as a benchmark for future research, and we believe maximizing the use of AI in the sector could strengthen Malaysia's food security, which then would lead to sustainable aquaculture development. These are the list of the references that we use in the study, and that brings us to the end. I'd like to thank you for your time and attention today. If anyone has any questions, please feel free to ask, and we will try our best to answer.
Excellent. Thank you very much. Sorry, apologies. I thought other person is making a presentation, but that was by Amiera Syazlin Azhar presenting. Do you have any questions verbally? So while you're thinking about questions, Soprani has a question. So can this method apply to other parasitic species? And then I had exactly the same question.
Hello, hi.
Hi.
Thank you for asking. Actually, this is like the first stage of our research, and we plan to expand our knowledge by exploring more algorithms to improve detection accuracy. And in the future, we would like to not only focus to one disease, as we want to learn more and more on disease, and we could create a better system with more type of disease in the future.
So this is about image processing, so to
Yes.
detect external parasite. So do you have any other sort of a variance, like a water turbidity or a popular number of fish, stock density, that kind of thing? When you tested 30 fish, infected, non-infected, did you check other variants like a water turbidity or stock density?
So far, we only use one type of fish and one type of disease during experiment.
Yep.
And,
okay. Yeah.
And And all of the parameters are controlled, such as turbidity, pH, and temperature.
Yeah, that'll be interesting further research, I guess. Thank you.
Yeah.
Yeah.
Thank
And
you. Thanks for the suggestion.
so there are the question coming up. So in early detection of the disease using developed AI protocol, what are the possible preventative measures that can be applied to prevent outbreaks? So this is used for early detection. What kind of preventative measure or maybe treatment? Do you have any sort of suggested strategy for early detection or preventative measure?
For the time being, this system is actually created to assist, to ease the participation of fish experts, and at the same time assist fish farmers. So actually, this system was created to actually to early detect the protozoan white spot disease, so that the fish farmers can take early prevention from any further worst case scenarios.
Yeah. So similar to my question, this person is asking, image detection technique may apply in cage culture with high turbidity? That might be the question, isn't it? If water is really
for the first stage, we use experiment in like small aquarium, but in the future we plan to expand our knowledge, and we plan to create one prototype to be used in the fish farms.
Yeah.
So that
this
our
is
system can be used worldwide.
This is the future diagnostic method for those parasite infests.
Yeah, correct.
Great, thank you very much. So
thank you so much for the questions.